This lesson is a continuation of 10.7. So if you already have the objective and essential question written down, you don't need to do it again. We're talking about combinations now. A combination is the selection of things in any order. For example, if no letter is used more than once, there's only one combination of the first three letters of the alphabet. ABC, ACB, BAC, BCA, CAB, and CBA are considered to be the same combination of A, B, and C because the order does not matter. Think about if you go order a combo at a restaurant. You might get a cheeseburger, french fries, and a drink. It doesn't matter what order they give those things to you in, you still have a cheeseburger, french fries, and a drink. If no letter in this scenario is used more than once, there are 10 combinations of the first 5 letters of the alphabet when taken 3 at a time. To see this, let's look at the list of permutations on the next slide. These are all the permutations where order matters. Grouping these together, the first 6 permutations in that column are all considered the same combination. So each column that we have is one combination. Since there's 60 permutations, each one's repeated 6 times, there's a total of only 10 combinations we can create. The formula for finding the number of combinations of n things taken r at a time is NCR, or we like to say choose, which is the permutations divided by r factorial. So what that boils down to is right here, n factorial over r factorial times n minus r factorial. It's the same as permutations, but now we have r factorial in the denominator being multiplied. So let's try it out. Mary wants to join a book club that offers a choice of 10 new books each month. If Mary wants to buy 2 books, find the number of different pairs she can buy. So this is a choose combination because she's buying the 2 books, but there's not an order that matters. So it's 10 choose 2. So following the formula, that would be 10 factorial divided by 2 factorial times 10 minus 2 factorial, which simplified is 10 factorial over 2 factorial, 8 factorial. Remember, everything's multiplied together here. So if we list these out, we'll be able to eliminate from 8 factorial all the way down. We can also continue to simplify with the 2 that we have in the denominator. So we could do 10 times 9 divided by 2, or we could simplify by saying 10 divided by 2 is 5, and 2 divided by 2 is 1, and that would give us 45 divided by 1. So there might be additional simplifying that needs to be done in combinations. So there are 45 combinations and different pairs of books that Mary could buy out of the 10 new books each month. If Mary wants to buy 7 of the 10 books, find the number of different sets of 7 books she can buy. So again, because it says a set of 7, it doesn't matter the order, so it's a combination. So 10 choose 7, plugged into the formula and simplified, and then expanded. We start with the largest numbers, so we can get rid of all the 7 through 1 in the first part. So now we have 10 times 9 times 8, and 3 times 2 times 1. And if we were to reduce this, we could try to do combinations. So 3 divides into 9 3 times, that equals 1. 2 divides into 8 4 times, that equals 1. So now our denominator is completely wiped out, and it's 10 times 3 times 4, which is 120. So what looks to be daunting at first really isn't such massive multiplication once we do some simplifying. So there are 120 different sets of 7 books that Mary could get out of the 10 available. Harry wants to join a DVD club that offers a choice of 12 new DVDs each month. If Harry wants to buy 4 DVDs, find the number of different sets he can buy. Again, the way that we know this is a combination is because it's talking about sets of DVDs, so the order doesn't matter. So 12 choose 4, plugged into the formula and expanded. Cancel from 8 down. To continue canceling, 4 times 3 is 12, so I can cancel the 4, the 3, and the 12. 2 times 5 is 10, so I can reduce that down to 5. So now I have 11 times 5 times 9, which is 495. If Harry wants to buy 11 DVDs, find the number of different sets of 11 DVDs he can buy. So now it's 12, choose 11, which simplifies a little bit easier. And it ends up being 12 over 1, which is simply 12. So there are 12 combinations. That means Harry can buy 12 different sets of 11 DVDs. Hopefully you have a grasp on the difference between permutations and combinations. You try to use the formula as best you can, and make sure your notes are filled out completely.